Okay, this red line right here is the graph of the right-hand branch of 4 minus x over 5 plus x. There's another branch over in here somewhere, but it doesn't apply because we only get rectangles bounded by the axes for this right-hand branch. Now, if you take a look at this rectangle that I have inscribed in that region right there, if I call this length x and this distance f of x, then the area of that rectangle is this x times this height. That's a function that will give you the area of this rectangle. And just so you can see what's happening, here I am on Desmos where I'm letting x sub 1 vary from 0 up to 4. And down here we've calculated the area. And you can see as I let x move this way, that area is getting bigger and bigger until we get into the vicinity of 1.7. And then the area seems to be getting smaller. Okay, so we have to find the x-coordinate between 0 and 4 that gives us the maximum area. And that's where calculus comes in. Okay, so here's the area function. This length or width times the other dimension, which is f of x. And I've rewritten that as minus x squared plus 4x over x plus 5. In order to find out the critical number for this function, we have to find the first derivative using the quotient rule. So denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Simplifying the numerator and putting it in descending order, there's your derivative. And to find critical numbers, we want to find out when does this equal 0. Of course, if we multiply both sides by x plus 5, the quantity squared, we'll just get the numerator equal to 0. Another way to think about it, a fraction only equals 0 when the numerator is 0. So we want to solve this equation right here. And if I go to board 2, there's that equation. When I see a quadratic equation where the leading coefficient is 1 and b is evenly divisible by 2, or it's an even number, I usually just use completing the square instead of the quadratic formula. So the number that completes the square is plus 25. X plus 5, the quantity squared, equals 45. Take the square root of both sides. Get plus or minus 3 radical 5, so x equals one of those two values. But we want an x value that's between 0 and 4. We could apply the first derivative test to show that this number right here, negative 5 plus 3 radical 5, produces a maximum area, but I won't go into that. So there's the value we're going to use. And that's about 1.708, etc. But that's not the answer to the problem. We want to know what is the maximum area. And if I plug this number into the area function, and on Desmos I had to use the letter R for the area function, the area is about 0.5835. So if I go square units, if I go back to Desmos and change this x sub 1 to that x sub 2 value, there is the maximum area right there. So there's kind of what the rectangle looks like. Okay, there you go. Hope that helped. If you have any questions, post a comment. I'll stop sharing and end the recording.